Today's lesson is on section 2.3, subtract real numbers. We just recently went through the section that was 2.2, which was adding real numbers, and we talked about some nice strategies to use when you're adding positive and negative numbers. We talked about using a number line as I have up here as one possible strategy. We also talked about thinking money. We talked about temperature. We talked about the mental math way. And if you want to review those methods, go back and look at the section 2.2 of that lesson. But the thing is, those work great when we're adding real numbers. Subtracting real numbers, well, then that would require some new strategies or some different things we would have to do. So if we're going to subtract real numbers, we actually just kind of a sneaky way of subtracting real numbers. We're just going to take any problem where we have to subtract, and we're just going to change it into an adding problem instead. And once we do that, then we can use one of our strategies. So then this section just turns into, well, how can I turn a subtraction problem into an addition problem? Because if you can do that, then we can still use our strategies like thinking money, number line, mental math, whatever it is. I'm going to teach the way that I learned when I was a student learning positive and negative numbers and how to add and subtract them. I learned a method that my teachers called chop chop or chop dash. And I'm not sure if they like karate or were ninjas or what, but that was the method I learned, and it just shows a way that you can change subtraction into addition, and then if you change the sign of the next number, that will change the problem in a way that you can still get the correct answer, and then it's just an adding problem instead. So that's the method I'm going to use. I know Mr. Tyson and other teachers before, Mr. Kaviter, Ms. Sauk, I know they used maybe a different strategy. What I usually tell students during this section is if they want to use one of those strategies and those work for you, then and you're getting the right answers, then I'm fine with that as long as you understand it. But I'm going to show this way because this is the way I learned, a way that I think is still pretty effective and works pretty well, and also I think works nice for algebra too. So in terms of changing signs and doing it carefully but getting the right answers still. So again, here's what happens in my methods when either you do a chop chop or a chop dash. Here's some example problems where you might execute one of these moves. And again, what we're doing though, just remember, here's the main idea and why we're doing this, is we're changing a subtraction problem into an adding problem, because then we can use one of our strategies for adding negative and positive numbers. So this first problem I have right here is 17 minus negative 40. In a problem like this, here's what chop chop looks like. The first chop means that I'm changing this subtraction problem into an addition problem. So I draw a line here, again, like chop. I chop that subtraction sign, and really I just change it into an addition sign. Then the second chop means I have to change the sign of the next number. And in this case, it's negative 40. So I chop that also into an addition sign and make that positive 40. So here's what this problem now looks like. Actually, I think I can slide this way. Yeah, there we go. Here's what this problem now looks like. Now that I've changed it, it really just becomes 17 plus 40, because I changed the subtraction to addition, and then I changed the negative sign on the 40 to addition. And that will give me the same answer as if I punched in 17 minus negative 40. It's the same thing as 17 plus 40, which is 57. For the second problem, again, right now, if you have a calculator, punch this in and see what you get, or pause the video, run and get one, punch this in and see what you get. Negative 12 minus negative 21. Okay, you should get some kind of answer there. I'm going to show you it's the same thing as if I apply the chop chop method. So to do this, again, the first chop means that we're looking for subtraction and change it into addition. That's what we're trying to do. So which of these is a subtraction sign? It's really this first one. So that's what I'm going to chop in this case. And then I'm going to change the sign of the very next number. So it says negative 21. I'm going to chop that and make that addition. Whenever we do chop chop or chop dash, the moves are very close together. We change subtraction to adding, and then change the sign of just the next number to whatever the opposite is, whatever the sign it wasn't before. So this problem, negative 12 minus negative 21, we chop chop both the subtraction sign and the negative 21 to make it negative 12 plus 21. And what do I get for an answer now? I end up getting 9 if I use one of my strategies, like I owe somebody $12. I have 21. I can pay off my debt. How much will I have left? I'll have $9 left. And again, that should be the same answer that if you punched it in the calculator. If you punch in negative 12 minus negative 21, it should be the exact same answer. So that's what chop chop looks like. It's when we chop a subtraction sign into an addition, make it addition, and then the very next sign is negative, and so we make that positive. So chop dash, what does this look like? Okay, well, again, that first word, chop, means I'm going to change a subtraction into addition. That's still what I'm trying to do. I'm making these addition problems. So I'm going to chop the subtraction sign, make it add, but then now this next number is 31. I have to make it negative 31 for this to work. It was positive, now I got to make it negative 31. As soon as I chopped it, it was positive 31. I got to switch it and make it negative. So now it's negative 19 plus negative 31. And again, then I can use one of my strategies. Let's say it's number line. All right, let's say it's the mental math. I have negative two signs that are negative for both numbers. So that means my answer is going to be a negative number. And if I add the totals, then I'm going to get negative 50, which is the same thing you would have got if you would have punched in negative 19 minus 31. Okay. Same thing for this last one. Chop dash means, the chop means I'm going to go to a subtraction sign. Again, this negative 80, it doesn't mean I'm going to chop that, because that's just telling me that that's negative 80. Okay. This sign here in the middle, this is subtraction. So that's the first move I'm going to make. I'm going to chop that and make it addition. And then the very next number, now I've got this as positive 20 here, it looks like. So then I'm going to make that negative 20. That's where my dash comes in. So I make a little dash, make a negative sign, so it's negative 20. Negative 80 plus negative 20. Okay, maybe this time using number line, I'm at negative 80. I'm going to go 20 spots to the left. I'm going farther in the negative, so my answer is going to be negative. I'm going to end up at negative 100. So again, that's the method that I've learned in the past, and the method I'd like you to try. If Mr. Tyson's method works a little better, or a teacher from before, Mr. Kaliter, Ms. Selk, if one of their methods works better and you're getting the right answers, I'm okay with you using one of them, but I'd like you to at least try mine and give it a chance. Here's also what I'd like you to write down if you're taking notes along with me. Here's also what I'd like you to write down as kind of to help with some of the common mistakes that I see sometimes when we're doing chop, chop, or chop dash. It means that you make two moves that are just right next to each other, two lines, two changes right next to each other, like I was doing where I was chopping the subtraction sign, making an addition. And then the very next number I change, just right next to it. It doesn't mean I'm going to chop everything in the problem or jump over numbers to make another chop, so it's just going to be right next to each other, two quick little moves. Okay. Here's what not to do. Here's some examples that I see of students, some things that I see on assignments or in tests. Here's what I see them doing when I walk around after we talk about chop, 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 or chop dash and chop, chop. I'll see them do that exact thing as I said there on this first problem. They'll go chop, chop, chop. They'll do every single negative sign or subtraction sign, and they'll make it a positive. Okay, but I don't want to do that. Okay, that's not what I'm trying to do. In this problem, the first one I always look for is a subtraction sign. That's what we're doing. We're turning subtraction signs into addition. So because we're going to add instead. And I know in this program that I have here, it's kind of hard to tell the difference sometimes. But really, this is my subtraction sign, as students should know, between the two numbers here. So I'm going to chop that and make that addition. And again, the very next number is what I'm going to change. It looks like negative 40, so I'm going to change it to positive 40. So this problem really becomes negative 10 plus 40. And that gives me positive 30. Okay. Same thing with this next one. I'm going to show another common mistake that I see. I talk about chop, chop. So some students will go, oh, chop, chop. And they make those both positive, and then they just add those two numbers together. In class, I'll ask, but what's wrong with that? That's not what you should do. Okay. What's the problem with that? What's my mistake? And students will usually be able to figure out that I'm not gonna chop that negative 15 out front. My first move is always with a subtraction sign. So which of those is telling me to subtract? It's really this one right here. So I'm gonna chop that, and then I keep moving this way. I don't go backwards. I don't jump over a number to make another chop or anything. Okay. Again, like we talked about above, chop dash or chop chop. It's just two moves that help change the problem, but they're right next to each other. Okay. So I make a dash for that next number, 65. I'm going to make it negative 65. So this becomes negative 15 plus negative 65. I could think of money. I owe somebody $15. I owe them 65, so I owe them all that money together. I owe $80. Next, we'll usually go through a few examples just to see how students are doing on these and if they can kind of execute those moves themselves and be able to come up with the right answers. Like I mentioned before, I'm okay if students use a method that Mr. Tyson or Mr. Cleveter or Ms. Sauk used. Here's one that I see them do sometimes, as opposed to chop chop. Sometimes when students see these negatives right here, a subtraction sign and a negative, I should say, they know that if I just make a big plus sign, that's really what happens too. They end up adding those two numbers. And again, you'll see you get that gives you the same answer as if you use my method of chop chop in this case. So again, if that works for you, you can use that as well. Okay. Again, here's the way I'll talk about it though on the board. I'm going to chop the subtraction sign, make it addition, and I'm going to chop that negative sign and make it plus. And so a positive 20, so now it's 21 plus 20, which also gives me 41. Either method gives you the right answer. So whatever one you're comfortable with, and whatever one gives you the right answers. I want you to be able to get the right answer. So however you do it is fine with me. But here's the way that I'm going to show it up on the board. This is the method I used, and this is the method that I still use. 29 minus 36. This one is subtraction, so I'm going to chop that and make it addition. And then I'm going to make a dash in this case. I'm going to make that negative 36. Again, why do we do this? Why do we do this chop dash, or why do we make the big plus sign, or any method we use? We're changing this to an addition problem because now I can use one of my strategies that we learned before. Let's say I'm at 29 and I'm going to go to the left 36 spots, just like a number line. Okay. If I'm at positive 29 and I go to the left 36 places, am I going to get past 0? Yes, I am. So I'm going to have a negative answer here. How many places past 0 am I going to get? I think it's going to be in negative 7 places. So negative 7 is my answer. These bottom two, negative 200 minus 150. Again, here's the first place I'm going to make a change, the subtraction sign. That's what I'm trying to do, is make these into addition problems. Because then I also feel like adding is a little easier for our brain as well. Adding is a little easier than subtracting when we're talking about some of these strategies. So I'm going to add these two numbers, and then I got to do the dash. So again, if I just kind of make the two quick moves, it really just is like chop dash. That's what I end up doing. So negative 200 plus negative 150, I end up with negative 350. And then number 4 here, this one also has got a couple negatives, a subtraction sign, but here's where I'm going to start. The subtraction sign is where I want to begin. I'm going to chop that, make it addition, and then I go to the next number, and that's the one I change. I don't go back. I'm not going to go back in front of the other number. So I'm going to just chop a subtraction sign, and then the very following number, change its sign. So this is chop chop. Negative 40 plus 95 gives me positive 55. Just a few other examples of what students might see in their homework as well. We dealt with these kind of problems in the first section we did this year, section 1.1, so as kind of a review. And so this will come as nothing new. Sometimes we have to evaluate problems, and they'll tell us what the variables stand for. In algebra, this happens a lot, so we'll expect this all year long. But some of the problems might look just like this, like problem number 1, y plus x. And then they tell me what y and x are. So I just got to plug them in and go ahead and evaluate and find the answer. Evaluate means find the final number. Okay. Again, just as a reminder, you don't have to write the problem down in your homework. So here might be what you would write down in your homework. You'd put problem number 1, and then you just plug the numbers in, like 12 in for y and negative 4 in for x. And then you can go ahead and just find the answer from here. 12 plus negative 4 in this case would give me 8. So that's all you'd have to do for that problem. You don't have to rewrite the problem if you don't want to, but what I have in blue here could be your work and your answer. Same thing for number 2. Negative 10 minus 20. I just showed. Okay, here's my work. Problem number 2. I plugged in negative 10 for z. It's minus 20. It's a subtraction problem, so I'm going to chop dash here and make this negative 10 plus negative 20. And that gives me negative 30. Again, as I'm doing these examples too, you can pause the video and kind of do them along with me, or try to do them first to see if you get the same answers I'm going to get here in a few seconds. Not a bad idea to kind of check and see if you're understanding things so far. Number 3, 10 minus x. And they tell me x is negative 4. So 10 minus, well, negative 4. Here's a case where I'm going to chop chop. So I'm going to end up adding, and all I'm going to get is 10 plus 4 in the end, which is just 14. And this last one, z is negative 10, x is negative 4. So I plug those numbers in. Here's what it'll look like for my fourth problem. -10 minus -4. Here's where I chop the subtraction sign and then that next sign to make it positive. So +4. -10 plus 4. I can think about one of my strategies. Let's say I'm at -10 on the number line. I go to the right 4 because it's a positive number. It's adding a positive number. Am I going to get to 0? No. So I'm still going to be in the negatives. How far in the negatives? I'll still be at -6. So again, why are we changing these problems? Why are we doing chop chop or chop dash or making the big plus sign? Why are we doing that? We're changing subtraction sign into addition. One, because it's usually a little easier for our brain to do those kind of problems. And two, then we can use the strategies we learned in the last section. So then it's nothing new. It's just being able to change these problems into addition problems.